Hello, everybody. Welcome to our last voice meeting of 2024. And today we have Ben Gibb-Reid with us from the University of York, where Ben is a lecturer. And as you can see, Ben is going to tell us about interpreting the phonetic variation of discourse-pragmatic features for applications to forensic speaker comparison. So this already suggests what Ben's specialty is. Ben focuses on forensic sciences and forensic phonetics and acoustics, but also discourse and pragmatics, which is quite an interesting combination. So I'm very excited, and the floor is yours, Ben.
Perfect. Thank you so much, Misha. Thank you for having me talk here. So, yeah, this what I'm presenting today is essentially a lot of my work on my thesis, but I'll point you towards different things I've published if there's more interest in the things as I go. The basic question that I'm going to talk about today is how well do discourse-pragmatic features perform in forensic speaker comparison? And I will define what I'm treating as these kind of features, but essentially it's beginning at frequent words and taking a subset of those words. How well do they perform in this task? So there's a little bit of background to this. If you're not aware, forensic speaker comparison, or FSC, sometimes called voice comparison, comparisons between recordings made by an unknown criminal and the known suspect. So typically it might be a recording, say someone has made a threatening phone call, and the police then interview a suspect, and it's a task of the forensic expert to suggest how likely the evidence is based on the fact that it's the same speaker or different speakers. So you've got to be very careful how you phrase the questions, but it is comparing these two samples of speech between an unknown criminal sample that might be a threatening phone call, voicemail, a WhatsApp voice note, body cam footage, CCTV recording, many different things, and usually a known recording of a suspect in a police interview room. So to do this, we actually utilize features of the voice. There's not a golden thing exactly. Most of what we do in forensic speech science is utilize different aspects of the voice. These can be segmental, vowel consonant realizations, formants, acoustic alignments of that, suprasegmental, pitch, the range of pitch, speech rate, voice quality, sometimes as well lexicogrammatical, so the choice of words people use, localized grammar or jargon. The main thing we're looking at is how variable these are between speakers, so how similar the two recordings or samples of speech are, but also how consistent these features are generally within an individual's speech. Do speakers do these things in consistent ways, or do they vary a lot depending on factors? So, for example, pitch is relatively variable between speakers, can be. Some people have a very high-pitched voice, some people have a very low-pitched voice, but it's not very consistent because I've woken up this morning and my voice was deeper. As the day goes on, my pitch will raise. So all of these things need to be considered. And part of the idea, just as a quick grab from Michael Jessen's excellent textbook, is this kind of separation, as you can see, 4 speakers represented as quite nice and separate with quite low within speaker variations. Now, generally, it's useful to kind of think about what the requirements of these features are. So I've mentioned that they need to be variable between speakers, and the within speaker variation must be low. They also need to be easy to measure because we're explaining them to often lay people. We're not explaining them at linguistic conferences, but it's being picked up by juries or police forces or judges or lawyers and applied to a context whereby not everyone in the room is familiar with vowel variation or phonology. So these things need to be explainable, but also they need to be easy to measure so you can explain your methods. They must be robust in transmission. Often there's a difference between a phone recording in the distributed sample and a police interview, resistant to disguise, and frequent in speech. And the starting point of my research was thinking about what things are frequent in speech. This is one of the major aspects that literature suggests are crucial for forensic speaker comparison. So why don't we look at this, rather than looking at things that tick the other things, actually what is frequent? Part of the interest in frequency is because across samples of speech, there's no guarantee that the same features are going to occur. So I've just got a Venn diagram here, imagining a scenario. You have the criminal recording, the known recording. they might have loads of tokens of trap in both recordings. You might have the voicemail recording, loads of like, the word bat, cats coming up, loads, and in the police interview, the same. You might have an overlap of L, for instance, if that was a feature of interest for that dialect, or if that was particularly useful, that's great. But you might have strut, strat in Southern British accents in the criminal sample, but not at all in the known sample. You might have price, not in the criminal sample. And you get the idea, TH fronting. All of these things, also TH, generally, all of these things might be useful, but there's no guarantee that they'll be across both samples. So the more frequent a feature occur in both samples and therefore provide a direct comparison. Now, feature such as filled pauses perform really, really well. So is better than but generally the way that speakers pronounce the vowel in a filled pause, be that or or etc., they're really, really useful, and they're used very widely within casework. So these are a nice established feature. And there's been other work, small scale attempts and kind of case studies, particularly by Phil Rose and Elliot, small scale attempts to use hello, okay, fucking, and yeah, looking at these specific words between speakers. Interestingly, Phil Rose talks about using dynamics of yeah from yes, really, really strong discriminants based on one word. He's able to separate speakers out. And he compared two speakers and took 35 background speakers just to look at the yeah from yes. More recently, Phil Rose and Bruce Wang have looked at Tayat, which is a Cantonese word. And it's a similar story. They looked at dynamics, F1, F2, and F3, and F0 as well. They found it was a slightly weaker speaker discriminant, but it had low error rates. So there's some suggestion, quite strong suggestion, that individual words, segmental measurements or dynamic measurements from individual words has value in forensic speech science. So the reason I focus on discourse features is partly their availability, but partly this kind of slightly other aspect, which I think needs to be controlled within the variation. So these are defined by Heike Pichler's work. It's kind of a combination of discourse markers, pragmatic particles, trying to avoid calling it one thing or the other and having a slightly higher order term. But they're syntactically optional, multifunctional, and discourse organizing. That's generally the definition. And they're very, very frequent in speech. So I've selected yeah and just. I also looked at like in my thesis. They're really frequent in British English. And yeah, particularly is very relevant for police interviews. If someone is not making any comments, but they're saying yeah or no to answer questions, that's really useful. That might be something people, even if they're not answering very much, they might say the word yeah. And we also know there is some phonetic variation already involved in words. As Jen Hay and proponents of exemplar theory, they say words are seen as vehicles for language change. If there's already linguistic change happening with these words, some of that change could be reflected in individuals. That's part of the theory behind this. There's a lack of research generally into phonetic variation of these features. And this is where I started at a forensic angle and suddenly found myself dragged into a very different and exciting angle of how do these things vary generally? Because there's predictions around grammaticalization, slow changes in meaning, frequency and context from the exemplar aspects. How do these things turn up in, is it that like is always turning up here? And if it's, it's turning up here, then it's reducing all the time. And then there's also interactional functions from more conversational analytic angles. And research on yeah, just as an example, we have assessment and turn initial yeah, which is indicated as having longer durations and higher intensity. So if you are starting a turn with yeah and you're responding, you're saying, yeah, I like that too. It's likely to have a longer duration and be higher in volume. Freestanding back channel yeah. Some of these terms are questioned, but generally freestanding and back channel is just showing listenership. You're not taking a turn, you're showing listenership. If I was speaking and you were giving me feedback, you might say, yeah, yeah. Shorter duration, lower intensity. Question response, yeah, similarly, if you're just saying yeah to answer to a question, shorter, less intense. And then when yeah is passive, it's also likely to be creaky. So there's some findings that indicate there is already some mapping of phonetic features onto this word based on its context and based on its meaning. And I'm going to return to that research a little bit later on. there's a little bit of caveat here. Ideally, we want to use words regardless of functions. If each function of yeah has a distinct phonetic realization, that's an issue, because you wouldn't be able to compare every yeah with yeah. You'd have to compare response yeah with response yeah. You can't compare response yeah with back channel yeah if they're not phonetically equivalent. So that would actually counteract the frequency effect. So again, I'll return to this kind of issue when I discuss my results. But understanding how much the frequency and the grammatical effects or pragmatic effects of these words impacts their pronunciation is actually really helpful for forensics. Kind of that question informs the usefulness for forensics, as we'll see. So I'm just going to briefly talk about two major experiments in my thesis. So how well does the pronunciation of yeah and just perform? How do these perform in speaker discriminants? And then what else affects the production? If it's not individual, how can we control for the variation in the forensic context potentially? So I did kind of do a segmental analysis of these words. So I looked at the vowel phone midpoints, segment durations, and also fricative center of gravity. For yeah, I focused kind of replicating Phil Rose's work, looking at phone trajectories of yeah. And I did what's called likelihood ratio testing, which I'm going to very briefly introduce. But you can see there, I was manually segmenting annotating each segment of just, and it's following the preceding context and considering all these different things, but also the function there represented by PRE. I'll go into the functions in a little bit. If you're not aware of likelihood ratios, I don't have much time to go into crazy detail with them, but they're a standard forensic stats method. So they're assessing the likelihood of evidence based on two theories. The theory that they're the same speaker, which is often the prosecution proposition, the theory of different speakers, the defense proposition. So two recordings, is the suspect or defendant the person who made this criminal recording or not? So we're assessing the evidence, whether or not it would have occurred based on these two ideas. We often express it as similarity over typicality. How similar are the samples, but also how typical are they? If they're really, really rare, if these occurrences are really unusual, that might suggest that it's unlikely to find a match with anyone else in the same background of these speakers. Again, it's complicated thinking using Bayesian stats, and if you have questions, do feel free to ask. But it's splitting the data into three, and what I did here was replicate the test with different groupings based on previous work on this. So it's a statistical method to kind of replicate the casework context, because obviously I'm not using actual case data here. I'm using kind of corpus speech. And there's two figures that I'm using throughout this talk to kind of assess how well just and yeah and other features are performing. Equal error rates. How many times is a system or this stats test incorrectly matching speakers and saying, oh yeah, those two are the same speakers when they're not, or oh, they're different speakers when they're the same speaker. And then we have CLLR. That's the size of errors. So when it's making an error, is it being really confident in its errors? All you need to understand is that the lower these figures are, the better the system. So we're looking for lower EER, lower CLLR, and that indicates a better performing feature. So for just, I looked at DIVIS, which is SSBE speakers from Cambridge, generally, and these are simulated police interviews. I took a relatively large amount of tokens. It was frequent in my data, which was great, 0.88 per 100 words. Around about 1,000 of those were suitable for vowel analysis. And I had a restriction on how many speakers I could use. I had to use 6 tokens per speaker because of the amount you need for it to do likelihood ratios. Now, as I mentioned, I took the vowel midpoints, center of gravity, and segment durations here. And I also looked at strut and the vowel in Strut canonically is the vowel in just. So for SSBE speakers, they might be expected to say just as opposed to, I might say just from a different dialect region. But strut is canonically the vowel in just. And the vowel in as I mentioned before, is a good forensic feature. So I'm comparing an unknown forensic speaker of just with a good feature of and the kind of canonical vowel that we expect to be performing relatively well. But the predictions around this particular population, they've not been tested in this way. So we'll see. So out of my 100 male speakers, I had a wide range of vowel pronunciations. So here we have all the just tokens represented by little blue diamonds, and they're overlapping with generally where the speakers are producing kit, a little bit with where speakers produce and a very slight amount with strut. So I'm going to play a couple of these to show you the range of pronunciations. Hoping this is going to play through. Just. So there's 4. I'm going to play those each again. So that first one there just is quite high in front. Then we have a slightly more back pronunciation. It's very, very short. And then we have a more like pronunciation. Just. And then we have a more back pronunciation. Ja. So these actually were 4 different speakers. And this just represents the 4 speakers that had the highest and lowest F1 and F2. So they're kind of what you might call the periphery speakers. And what I was finding generally was that speakers were pronouncing the vowel in somewhat distinctive ways, somewhat separately. There's a little bit of overlap there, but there seems to be some separation between them, which indicates that there is decent between speaker variation, but also relatively small within speaker variation. And this is what I found when I plotted out just, and strut. And again, remember that as my huge green arrows show, the lower is better. So is performing best, and then we have just, and then we have strut. So what we have here is just indications that just is a relatively good speaker discriminant. It's performing comparably to It's a little bit worse, but this scale is quite small to show the difference. There is a difference there, but it's a relatively small difference between just and So just is performing comparably to but nowhere near as bad as strut. And when I included segment durations, as opposed to that was just for the vowel formants across those 3 vowels. If you look at the red dot, that is the same model I showed you before. And this is what happens when I add in duration measurements. So when I add vowel duration to a model that includes vowel formants, it improves it. So it's a lower EER, lower CLLR. So it's a better system for speaker comparisons. The other results are a bit of a combo. Adding in S duration, the errors are less bad, but there's a few more of them. And so it's a little bit, the only one that is clearly lower for both of my metrics is the kind of purple box of vowel duration. So adding vowel duration seems to somewhat improve the speaker comparison. So doing formants and vowels duration is pretty useful. Adding the center of gravity for S also improves it. And here we see the triangle there is center of gravity for S, including J, center of gravity, actually seem to reduce performance. So just to summarize that, it's a lot of kind of statsy things there, but the overall picture is that just is performing better than strut and comparably to So looking at the vowel formants is useful to kind of compare. I looked at the vowel formants in each of those features, and in the same subset of speakers, the same data, just is performing in the same area as And it's a really highly frequent feature, and it was relatively easy to measure. I didn't, I could extract a lot of vowel tokens, even if they're very short. I was able to extract pulses of the vowel. The vowel midpoints have a good FSC performance, and part of the easiest to measure consideration is that even though I include vowel duration and S center of gravity in there, those differences are minor. Actually, including vowel duration, including S center of gravity, they're very marginal improvements in performance. I'm not seeing like a huge improvement, which makes me think that you could use just, pardon the pun, the vowel from just as a speaker discriminant, as opposed to using all these different extra measurements. Small improvements, but you can analyze the vowel alone. So now moving on to yeah. I use slightly different data for this, partly because there was a need to consider more conversational data. The police interview would not elicit the same amount of yeah tokens, but also I wanted to look a little bit at phone data for this as well, because Phil Rose had previously looked at yes using phone data, and I thought it'd be good to replicate the way he'd approached that. So this was 44 male speakers, now West Yorkshire English, paired phone conversations, and the data had been aligned using Montreal Force Aligner. So I was adjusting that alignment, as we see, to some success. But I was also, there'd been some work there already in aligning things. I also used an automatic speaker recognition system. This was just to see I didn't do this with the just data. I kind of ran out of time in the thesis, really, but automatic speaker recognition is you often test new methods against an automatic method, because the automatic method will give you very, very, very good results often. So I use that as a kind of, rather than looking at for this data set, I looked at an automatic methods as a comparison. And so I took a slightly smaller selection of from 33 speakers, and this splits the audio in two and does a similar analysis. So for this, I use Fulmont dynamics because you can't just take a single vowel token, it's always moving. I had to do a lot of data cleaning, which was very tricky. And I used quadratic polynomial coefficients, but essentially reducing 9 measurements across every year to 3 to capture the curve. Okay, so similar kind of plot for as we saw for just. This time we have kind of these little small red diamonds representing every token. And we can see actually is overlapping with a lot of vowel spaces. I included more lexical vowels here because was actually overlapping a lot more with them. So sometimes would sound like this. Very, very short, but very close. It's quite quiet, but sometimes it was a bit more open. And then you had tokens where there's a lot more movement. Oh, sorry, a lot less movement. So the movement between the kind of glide and the vowel is almost non-existent. Then we had kind of, more movement, less movement. So, and then sometimes I also had these ones that were really open at the end. This last one here. The reason I have a selection of these is actually, again, in opposition to the last example, is that these were all one speaker. So what I was finding here was, with just, there was a nice separation in some of the quality, whereas with what I've done here in the plot is measure the midpoint, but I'm playing you the full range of one speaker was producing in very, very, very different ways. So when I did a similar likelihood ratio test, this time comparing the ASR analysis with mainly the ASR analysis is just telling me my data is good. Like my data there is a way to use the data to separate speakers. And it's performing with a CLR of over 1, which shows it's very problematic. That shows that is actually not offering anything speaker specific. So it's quite problematic results. I include the LLR figures there as well to show that there's no separation. You should have one of those as positive, one of those as negative, and that's not what we're finding at all. So SS, same speaker comparison, should have a positive LLR if you're interested in those kind of things. So it's coming out rubbish, frankly. And again, as a reminder, we had this nice, 0.65 kind of CLR. Those are absolute results. They're better in comparison, but we see that is coming up way higher, 52% equal error rate. So again, just to illustrate, is off the scale that we have for that previous plot. Different data set, so not the best way to compare, but we can see that it's performing poorly. So what we have with is a highly frequent feature. It is easy to measure. There's tried and tested ways of measuring forward trajectories, but it was very hard to segment. Actually, I was correcting the MFA. The Montreal Force Aligner did a very, very poor job of extracting I spent a lot of time adjusting those things, and data cleaning was tricky. And those choices, every step along the way, I was having to make choices about my data. Whereas with just, it felt like a relatively straightforward choice of, is there a vowel in just? Is there not a vowel in just? Can I take a measurement? With it was, well, okay, the token's here, but it's vocalic. So on one side, it's, on the other side, it's eh. If it's followed by another vowel or preceded by a vowel or an approximant, then how much can I trust these measurements? And it was very, very tricky to segment. As I've shown, performed very poorly in speaker comparison tests. 2 speakers did show some discrimination potential, which I talk about in an article that's forthcoming in IJSLL. So to summarize, using discourse features in forensic speaker comparison is complicated, just as promising, and is much less useful. And to briefly talk about the difference, I have to return to the other side of my thesis, which is the discourse-pragmatic variation. Why are these two things different? Well, they're different forensically, but that seems to be indicated by the general variation in usage of them. So yeah, I keep using this word. In my in an earlier part of my work, which is a slight pilot study for this work, I didn't do likelihood ratios here, but I looked at the functional and contextual variation of yeah in West Yorkshire English. So this was looking at feedback or pre-pausal yeah. So here the example I've got. I think I've got the whole thing here. Oh no, okay. So if you were to respond, if you had speaker A saying, so that's me, speaker B saying yeah, and speaker A saying anyway, how are you? It might sound like this. Very little movement between the approximant, if there even is one there, and the vowel. It's a very flat F2 curve. That's what I was measuring there. Whereas when we have response and incipient yeah, it might sound like this. That's responding to a question, but also turn initial, and it's taking a full turn. Yeah, are you free? Yeah, I'm free. I am right now. So a wider range of forward movement. You can hear that difference between a clear glide and diphthongal vowel. Whereas for just, we have a slightly different picture, and they have different functions. Obviously, very, very different functions. But it's sometimes when you have just, which is used in a more discoursal way, so to kind of emphasize, or to kind of bring focus in a interactional way on the following, the kind of following part of your turn. So I just don't know him, or they're just sitting around. That is more of a, it's either minimizing or maximizing. And there's a lot of debates in literature as to how it's kind of diverged slightly, but nonetheless, these are specific ways of using just that are very separate from what I'll play you in a moment. So these were often had a elided vowel.
I just don't know him. I just don't know him.
I just don't know him, I'm afraid. And you hear it and you almost fill in the gaps, but when you listen to them individually, it is simply a
I just don't know him.
Just don't know him. It is a very short fricative burst. When we have an adverb token, that's more likely to produce with a full vowel, and often the t is also there. So an adverb would be like a adverb of time. So he just started there, or of place, kind of approximation. That's just down the road.
Well, he just started.
Just so you can hear, there's a clear, nice vowel pulse there. So what I found with yeah was that the quality of the whole word was very variable depending on its function or position, which affects the format measurements I was using. Whereas with just, the format measurements, there were some slight effects, which I talk about in this short paper here, but generally it was more to do with whether the vowel was present. So it's segmental presence or absence rather than the formant values of the vowel. The formant values of the vowel were relatively straightforward for just, and that seemed to allow it to have some individual variation in there, or to kind of permit the individual variation to be much clearer and less muddied by function. So the way yeah produced depends on function and context. However, the function affects the vowel in just less in terms of its quality. So to conclude, if you had a case whereby you had a criminal sample and all of the yeah tokens were like this, so he's like, yeah, took you long enough. And in the suspect sample, you had the police asking a question, you've lived there for 5 years, correct? And the suspect says, yeah, I moved before the pandemic. You're probably comparing one token that sounds like this.
Yeah.
So this lack of movement.
Yeah.
And one token that sounds like this.
Yeah.
Now, again, those are from that same speaker I played you earlier. And on first listen, they sound really distinctive. But to use this as a forensic speaker comparison feature would be slightly irresponsible, because in reality, they're separate phonetic predictions around those. So you cannot compare yeah with yeah in the same way you can potentially with just. Comparing yeah with yeah is complicated. There needs to be kind of functional or contextual equivalence there. So it's a less consistent feature of speech. This kind of within speaker variation is more tricky. So there needs to be some division into subcategories if you're to use it in speaker comparison. And to say Phil Rose, actually, when he looks at yes, he looks at a very specific subset of yes in his work. So that indicates why he found such good results, albeit on a very limited actual two speakers compared in a subset. He only looks at two speakers and then compares them with 35 of other speakers, where I was looking at huge cross comparisons. Whereas just seems to have some cross-functional usage. In terms of feature directions, just to briefly mention, I have a paper with Chloe Diskin Holdaway in Melbourne, kind of trying to look at if we can make a nice, clear way of describing what Yeah is doing. This is more discourse-pragmatic than it is forensic or phonetic, but it's looking at, we use a multi-level iterator reliability testing to kind of fine-tune a coding system to try and discuss how do we actually make these choices about functions. If it might be useful for forensics to have functional ways, how do we make decisions? Is this something we can help forensics with? But also, discourse-pragmatic variation also needs these schemes to do variationist studies of grammatical and pragmatic variation. I'm also really interested in seeing if distributions of Yeah can be used as opposed to formants of Yeah. This probably will be a slower burner thing because there's other work coming out at the moment relevant to this, which I'm really interested to see. There's work by Ishihara and Michael Kahn in Sydney. There's also work by Andrea Nini and James Tompkinson over in the UK, trying to apply some of these things, but fusing formant distribution measures, uniting kind of authorship analyses from forensic linguistics. I think there's a lot that can be provoked here, you know, combining discourse variation with individual variation. There's clearly a bit of a need there or an application there that's being explored. So to answer the question, how well do they perform? Well, it's complicated. Do they perform well? Yes and no. And actually, there's a need to discover, when we look at these individual features, what is individual, what is functional. There seems to be more than meets the ear, necessarily. There's some references if you're interested in more things. Just want to say a huge thanks to my supervisors and to Justin Lowe, who's helped me with a bit of the stats things, and Chloe, who I've worked with a bit in Melbourne. Yeah, so thanks for listening. I would welcome any questions.